All right, I want to go over the large example which I alluded to in the previous video with a number of different samples in here of things you could possibly use: radio buttons, toggle buttons, checkboxes, spin buttons, entry boxes, regular old buttons, a label, a tree store, and a text buffer, which covers a lot of territory. There are, of course, many additional widgets, and eventually I'll get to them, installing them and so forth, but this is a pretty good starting set. This is the file I'm going to post. It'll probably get bigger as time goes by as I put more examples in it. But there's a number of things in here I don't want to really deal with at the moment. We'll get to them eventually. But what is the map? What's really going on here? Well, first of all, you get this app-build.script. This is the one that actually reads Glade and generates files. What are the files it generates? It generates these guys down here. These include files. These contain code and code snippets that are used in order to create your app. I don't know what's even in most of these. Yeah, there's a bunch of declarations. These are the declarations of all the different things: window, GTK fix, button, toggle button, entries. These are all being declared there. That's where the declarations go. It's also including the GTK development files, which, by the way, you need to have the GTK development files for this to work. They're part of Linux. I don't know if they're default. You may have to load them. Okay, so they get created. These on units here are, I call them on units because I originally learned PL1, which what they were called back then. Something like that anyway. These are the files that contain the code that will be invoked when you do something to one of the widgets. For example, this is a clicked signal. When the load table widget is clicked, this file will be executed. When the radio 1 button is toggled, this file will be executed. Radio 2, radio 3. When the select one button is changed, that's the spin button. I think that's the spin button. This file will be invoked. Excuse me. Select is when you select a row in the tree store. I forgot what I called it. I gave it the name select one. It's not part of the, but it is a select widget that's coming up, so I just called it select one. This is where the spin value, if you change something in the spin button, this gets called. Spin value change. These are the functions that get called when you do stuff. So let's click on the on spin one value changed code. There's just a stub of code here. It really doesn't do anything. It's your responsibility to fill in what you want to do, but it does something. So it comes down here. It's running in Mumps. It executes a Mumps program, basically gtk4.h, which is down here, which is a bunch of set statements. And it sets up the references to all of the widgets so that this program that we are looking at can access the widgets. These are actually pointers, of course. But yeah, so where'd that go? It's hiding. I know it's hiding here someplace. All right. There we go. Anyway, so GTK4 basically sets up linkage to all of the possible widgets. You don't have to worry about it. It's going to do it. It's already in there. And this is just boilerplate. It writes out, hey, we're here. What do you know? I'm doing stuff. And then it writes out the value of the spin button. That's what's happening here. It's all it does. So if you say, so that's right. Mumps is a very simple language. It's much like original basic, Dartmouth basic. It's a write command, and this is the function. Functions begin with a $sign, and there's the argument to the function, spin1. So the functions are $Z, tilde, GTK, tilde, spin, GTK, tilde, and these names correspond to the actual GTK function, except they use underscores, but underscores mean concatenate in Mumps. So I decided to use the tilde, which actually I like better. It's easier to read, I think. Personally, it's easy to type too because it's right up there in the corner instead of the middle of the keyboard. Anyway, so every time it gets called, it's going to write out the value of the spin button, and as it goes up and down, you'll see the numbers change. Exclamation point means new line. So that's an executable. That's one of these files. Toggle one, when it gets toggled, it comes down here, and what does it do? It does basically, they're all going to do basically the same thing. Set up the linkage. They say, hi, there's my name. And then this one here happens to just go out and tell you what the value of the toggle button is. Is it set or unset, 0 or 1? And what you do then, that's how you find out if something is pushed or not pushed, set or not set, if it's active or not active is what the real term is. And that's actually the name of the actual GTK function, except they use underscores and they don't have a $Z in front of it. But anyway, there's the reference to toggle1 being the name in the Glade file of the toggle button in question. So this would be toggle1, I think. Yeah, it's toggle1, there it is. And the signal over there is on toggle1 toggled. So yeah, so these, let me get back up here to these. So these are the on units or the signal handlers that get popped up when you do things. So they get written out. I was saying apt build here is the program that causes the Glade file to be read, causes many of these files to be written, be created or recreated, and then it compiles part of it. Now look at this one here. You'll see that it has some other stuff in it. There's the /bin/bash, which gets stuff to bash, it kicks it off in a bash shell, gives you the date. These things here are my development stuff. It's deleting old versions of on button one clicked, on check one clicked, blah, blah, blah. It deletes these. So what happens when the program runs down here, extract widgets.mumps, you see it reads mumps.glade as its input. It writes out those files, but it would write out on button.one.clicked, on check one, it would create the files. However, if it sees there's one already there, it doesn't create it. It doesn't clobber it. So in other words, if you're doing development, it'll only create things that don't exist. If something already exists, it won't. Well, I wanted to recreate those the way I was doing development. So I left, so I have these RMs, so it deletes them. And then when the program runs, says, oh, there isn't one here, I'll create it. Okay, but this isn't all of them. Several of them are not deleted. But anyway, that's just because the way I was doing development. So if you see them in there, that's why they're there. They're to force this guy here to write them out anew. Otherwise, it would see from the previous run that they existed, and it wouldn't write them anew. All right, that's complicated. So this program here, it's a Mumps program. It's rather messy. It reads this in, and it generates all this stuff. The GTK 1, 2, 3, 4, all those on units, and probably a couple of other things, which I can't think of at the moment. All right, so it generates those things. And then it compiles gtk.mumps. Now, Mumps is basically, as I use it, an interpreter. But there's a version of my code which compiles it. And what's it doing here? You shouldn't use the compiler for everything because they're not exactly the same. Mumps C is the compiler. And it's compiling this stub here, gtk.mumps. Always the one it does. All right, so I'll go back here. What's gtk.mumps? The actual executable is GTK, okay? The compiler creates intermediate files. These two intermediate files are created by the compiler. You can delete them. I'll just bring one up here. It's automatically generated C++. C++ is hard enough to read anyway, but you automatically generate it. It becomes perfectly illegible. It's as though you sat on the keyboard. But yeah, those are automatically generated, and you can delete those. This is the input file to the compiler. These are intermediate files used by the compiler, and this is the output, the binary file. What's in gtk.mumps? Very little. All right. It includes gtk1.h. That's one of the files that was created by in a couple of lines before. The gtk.1 is got all the declarations in it. Okay, so it includes the declarations. I keep losing these things. They're disappearing behind me. Bring it up again. All right, because it was putting in a separate tab. I don't like it when it puts in separate tabs. I prefer separate windows. But anyhow, and I keep forgetting them. This tells it we're starting a main program. You get little warnings about that. Ignore them. GTK2.h. This is a bunch of code. I don't want to get into it, but it's code that is setting up linkages and so forth and names in the symbol table and so on. But yeah, it's a code item there. So yeah, but it was GTK2 was generated by that extract widgets.mumps or whatever it was called. Yeah, extract widgets.mumps. That's it there. All right. Then it does GTK4. GTK4 is actually assigns assigns pointer values to the references that are going to be used elsewhere. Okay. This here is only with regard to building that tree store. Okay, it's not. It's in there because of the tree store. So just let's ignore that now. It won't be part of yours. It's something you might want to delete. But it's only this actually reads in that mesh file, creates a hierarchical database of the medical subject headings, which I mentioned in the previous video. And since probably you may or may not have remembered that, the mesh headings are in here someplace. I don't see them down here. Yeah, there they are. That's just what the mesh headings look like. It's a name of body part, and it's a hierarchical index. So A01 is all body, A0147 is the abdomen, A014725 is the abdominal cavity, and so forth. So anyway, that's the program that reads them in and puts it into the database as a tree. But that's purely for example. It's not part of the of this GTK compiler example. Anyway, we'll just ignore that for now. It's doing it. You can see when the program starts up, it takes a moment for this to get done. It's a fairly large file. This here is what populates, just for test purposes. It populates the that text buffer. Let's get this off the screen. Let's do an example. And do I have a, yeah, here we go. Here. So if I say, let's see, whoops. Where am I here? Okay, it's actually doing the compiling right now. That was the pause there where actually the C++ compiler was running. Okay, now if I run it, GTK is the executable. Takes a moment. This is where it's building that tree, which we're not worried about. You see this stuff up here? See that? Okay. Where'd that come from? It came from this program right here. See these lines of code here? I won't get into it because they involve it. Well, it's set, x is the variable, equal to, this is a test message. There's the underscore, that's concatenation. $C10, that's ASCII 10 is a new line character. So it's concatenating a new line character in. There's another concatenation, and it's got some more text, and it can, then we take what was from x and we concatenate this onto the end of it, and then you know, so I made a long line whose name is x, a variable who's x, which has got contents in it. The point was I was testing out to see if the new line character, in other words, $C10, what the $C function does is you give it a number and it returns the ASCII character equivalent of that number, and 10 is the number for new line. And as you saw there, that was where there was a break in the text. Again, I'll bring it up here and you'll see it when it comes up again. After a moment, there it is. You see, this is a test message, new line. If it had been an actual test message, this is a wrap. Yeah, it ran out of space. One of them is a new line, the other is a wrap. You can see this is a test message. There's the new line. I was just testing. That's what it is. And then I populate the buffer. %sign is actually a legal variable name in Mumps, and I use it when I don't care what the value of the variable is. I'm going to throw it away. That's how I do it anyway. Notice there's no blanks in Mumps text. Blank is a delimiter. So I don't have a blank between the variable name and the equal sign. It looks very neat if you do, but if you do, it won't work. So no blanks, please, unless they're in quotes. Or they're deliberately needed, like between the keyword and the variable. In this case, a variable. Anyway, there's the function $, blah, 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 set buffer text. There's the, you have to tell it what the buffer is, and it's buffer1. That's the name of the buffer from the Glade file. And the thing you want to put in it. So X is put into text buffer, and that's why you see it. It was just testing. This isn't, you know, this is here because I'm testing and so forth. They are not really part of, you can delete those and everything else will work. However, the trees won't work, and you won't have that information in the text buffer. Then, it invokes GTK main. GTK main is the actual function in GTK that kicks off the whole thing. When you get return from this, everything's finished. So it sits there waiting for signals, and when it gets a signal, it calls the appropriate routine. And so when we return, it's bye-bye. We're all done, and we exit. This guy here, GTK3, this is where we get the actually get the linkages to those on units, or those signal handlers. And I know these are hard to read. since I don't have, you or I don't have to read them. Let's just see what we've got here. Yeah, this is one right there. Starts with extern, and the next one starts with the next extern. But it basically sets up a function. The function is called on clear store clicked. Clear store is the name of a button. Clear store is the name of clear store right there. That's the name of that button, clear store. All right. So on clear store clicked, it then proceeds to, it gets the pointer to the widget. It then proceeds to invoke the on unit. This is where it actually invokes that signal handler, which I'm variously calling signal handler or on unit. But the file that begins with on clear store click.mumps gets invoked right there. All right, and it passes down the widget with it. I don't want to get into what is really going on here because it's taking place. What it is it's in taking place inside of Mumps, and it. Oh yeah, that sets up the actual text. The text is actually set up in temp, and then this line here actually invokes it. That invokes the interpreter, passes down the command to the interpreter, passes down a pointer to the stack, and that causes whatever you have in on clear store clicked.mumps to execute. And when it returns, it frees the stack element. Anyway, you don't have to look at these, and it's probably better you don't, because that's running now. And it's got these stubs down here, so that when a signal comes in, one of these stubs will be executed. As a result, on clear store, here it is down here, will pop up and start running. And this is where you actually put the code. And it comes down by default. It, of course, does that linkage thing, and it says who it is. You can delete this, of course. And then it actually invokes a GTK function. The GTK function is tree store clear. And it gives the name of the tree store that we want to clear, which is the name of our tree store. It's called tree store, cleverly. Where'd my Glade go to? Tree store. Let's see down here. Let's see. It says tree one. Oh, tree one is the let me get it over here. Tree store. Where's tree store? Looking for the name here. I don't know where tree store is. Yeah, there it is, right there. Tree store. It's clearing. I got confused, what you do often enough. This is the actual tree store up here. This is the storage data structure. This is the tree down here with its parts. There's the select button, or that's not a button. It's when you select a row. That is what happens. There's the column 1, column 2, column 3. But if you see in tree over here under general, it's linked to tree store. Okay, so there's the tree, which is the widget you're appearing on the screen, and then there's the data structure containing the data, or the tree view model, and that's tree store. When you create it, you create both of them. So yeah, that's where tree store is. You don't actually operate on the widget; you operate on the tree store, and they're all up here. That's where I got confused. I didn't see it. Tree store. There's the text buffer, and there's the this is the one that holds the data for the spin button. It's called an adjustment. This is the text buffer, and there's the actual tree store. They're not visible themselves on the screen. The widgets are, but the widgets use these guys. So if I get down to the spin button, where it is there, oops, spin button, there's spin button down there, and I go to spin button, you'll see over there it uses adjustment 1. Okay. And who is the other one? This is the text buffer here, and you see the text buffer over here is actually using text buffer 1, which is up here. So those they're not visible items but they're part of the data structures used by the visible items. Okay, I didn't get into the weeds too much there, did I? All right, so that's how that pops up. Now back to wherever I was here. So this gtk.mumps gets compiled. So we've got apt-build.script. Apt-build.script. These are optional. They force it to recreate them. This is where it actually reads the Glade file and generates all those other files. This is where it compiles gtk.mumps. And when this happens, you get a file, you get these intermediate ones, which you can delete. But you get this one, which is the executable. You get something called GTK. You could change names and so forth, but at the moment, I'm not going to worry about that. So that's how it all actually works. Now let's go and take a look at some of them individually. We already looked at several of them. Here, first of all, there's the toggle example. Toggle button. What is it? Well, it's a GTK toggle button, and I gave it the name toggle1. You can give it most any name you want, but that's the name it's got, and that's the name you've got to refer to it by. All right, so I called it toggle1. It doesn't have any particular purpose other than an example, but if you're doing something, you know, if that's the toggle switch that turns off and on the transmitter, you may want to call it transmitter toggle or something like that. But okay, so that's the toggle button. Toggle button over there, there's its name. That's where the name goes. Most of this is boilerplate. You leave it as is. This is where you put the text down here that you want to have show up in the toggle button. Let me just check here. Something I just thought I might have been doing something wrong, but I'm not. It's okay. That's where the text goes. See, it says toggle example. So if you want to change that, if I want to make a capital T and capital E, you can do other things. You could put labels in here. You could put pictures in here. You can do lots of stuff. You see add custom content. Let's not get carried away, but that's where you can start dragging all sorts of funny things in there. But we're just going with text. Packing, that's where it's located. It's at position X81. I like even numbers. You know, I got two odd numbers there. And that's the left-right. This is the north-south. So it's at 80 by 12. So it's 80 across and 12 down is where it's located. And you can move buttons around, move things around with the packing. Common is pretty much going to be standard at this point. There's many things you can play here. One of which is you can height and width request. It's setting up now to use the height and width that are default for the amount of text I've got in it. Okay, but you could make it bigger, or you could, well, you can't make it much smaller, but you could make it, you know, substantially bigger. For example, in the width request here, if I just stand on it here, you see eventually it gets quite large. And -1 means ignore me. And I turned that off. But yeah, so you could play with the size. This is pretty much, you're not going to change much in here. There are some other things you can play around. If you want to get fancy with CSS, you can put it up here. But anyway, that one's probably the same, except if you want to go to some specific sizing. Signals, this is the important one. And toggle buttons have a toggle signal. There's millions of other signals, but they're not really relevant for the most part. Okay, they're signals because toggle button inherits from other things, and it inherits their signals as well. So if you've got occasionally you do. I mean, you get down to widgets, button press event. If you want to distinguish which button was pressed, if it's the left button, the right button, or the middle button, you start playing around with button press events. But you know, it's not all that common. I mean, I use it on some things, but for most applications, it's not there, and it's another level of complexity. But in any event, that would be another signal handler that would be automatically created. Although I don't have that written into the code, it doesn't see button press event yet. The code only sees certain things. But there it is on toggle1 toggled. It was the default name. So anyway, so the toggle example. So we look over here, toggle. Where is it? Toggle1 toggled, and there it is. This is what got automatically generated. And it shows you whether it's active or inactive. That's probably the most common function you're going to look at. It's going to return a 0 or a 1, indicating active or inactive. And when we ran the thing, you probably saw it go by. If I clicked it, runs that extra program at the beginning as it's building the tree. That's why it takes time here. You see down in the background here, you see I got 0 and 1 popping by. Every time I click it, that's depressed, and I get a 1. It's untoggled. I got a 0. See, it's being called every time I'm clicking on the toggle button. Now, what you want to do at that point, I don't know. I mean, you could actually write to other things, but you could do database stuff and things like that. All right, so that's how that one works. Let me get back up here. It's the radio buttons. Radio buttons, if you haven't played with them, again, we'll go back to general. I've got 3 of them, radio 1, radio 2, and radio 3. You can call them anything you want. This is where the names are put down here, where they get their names. And I just went with the 1, 2, 3. You can call them anything you want. Now, what makes them connected? Well, I get radio button 1. There's nothing special about it. It's got a location. There's nothing in here. The only thing it's got is on radio 1 toggled. It gets a toggle signal. Okay, but there was nothing else special. Radio 2, however, does have something different. Right here it popped up. The group. Radio 3 also has a group. See, it also says radio 1. In other words, radio 2 and radio 3 are linked to radio 1, which is not in a group. It is the group, I guess. So in other words, the way this is set up, radio 1 has nothing, no group. Radio 2 and radio 3 are both pointing to radio 1. It means radio 1's the default. When it comes up, that's the one that's going to be checked. And when you click on radio 2, it'll get focus, and radio 1 will be untoggled. And with this one gets focus, radio 2 will be untoggled, and so on. So they get linked by this group thing. One of them is the one that doesn't have a group name. It is the top of the heap, I guess, and the others are connected to it. So if I wanted to put a 4th button in there, everything else would be the same, but I'd also link it by virtue of radio 1. They all have the same signals. I mean, it's well, not the same, but they're similar. Radio 3, and the other one here has radio 2. Whoops, I hit the wrong one. Radio 2 toggled, so it's radio 1 toggled, radio 2 toggled, radio 3 toggled. Okay, and again, if I go over here and I run it, probably should leave this up. Okay, now in the background here, you're going to see a couple of you're going to see a couple of things. If I click to radio 1, you're going to see 2 toggle signals. You're going to see radio 1 toggled, and you see radio 2 toggled. Why? Because radio 1 got toggled off, and radio 2 got toggled on. So when you click from one radio button to another, it's actually 2 events taking place. One of them is being toggled off, and the other is being toggled on. And when I hit this one, you can say 2 is toggled and 3 is toggled. Now it will be 3 is toggled and 1 is toggled. So you get 2 toggles for every radio button hit. And again, you could let me get this off here. And let's see, where was my regular toggle button here? Radio was the other toggle button down here, so I don't have to spell something. Radio 3 select. I don't see it. Oh yeah, it is there. Let me just capture that, and now let's bring up let's say radio 1 toggled, and I will at the end there, and I'll paste in, but I have to change the name because that's asking about check 1, which you could find out if check 1 is toggled, but I don't want to find out. I want to find out if radio 1 is toggled. Okay, I spelled it correctly. Let's do 3 of them here. So I will now go over here, and I'll say 2, and I'll say 3, and I'll say, I need to put some explanatory text in here. Quote, radio 1. Sounds like I'm on the BBC. Did I type radio 1? Yeah. And a comma. And it's just a quoted text. It's comma list. Quote, radio 2, space, quote, comma. And I hope I'm not making any syntax errors. Quote, radio 3, space, quote. This will tell me the status when radio 1 is toggled of, save it, and see, I quit this thing here. Didn't have to. I could be editing it on the fly because nothing's compiled here. Now when I click radio, okay, I click radio 2. When I click radio 2, the radio 1 toggle came up and it told me 1 went to 0, 2 went to 1, and 3 is 0. Now if I click radio 3, you're only going to see radio 3. If I click radio 1, we're going to get that's the only one I changed. And see, radio 1 is now toggled, radio 2 is not toggled, radio 3 is not toggled. and I could reproduce that across all of them. Now, I didn't have to recompile or anything, because all I did was change one of these on units, because they're not compiled. I can change them dynamically as I'm running. If I open up another, well, I don't want to open up the terminal here. I would want to, let's say, open up, let's see, radio 2 toggled, and since this is all the same code, I'm just going to cut it here. I'm going to paste it here, because they are the same names, and I'll save it. And let's bring up radio 3. Then we're going to make a real mess of this. Okay, and I'll save that too. And now the thing is still running back here. So if I hit radio 2, we're getting a lot of them now, because they're all each one of them is giving me a cascade. But you see, I changed that on the fly, and I didn't have to recompile, because so this is where we enter radio 3, and radio 3 is getting toggled. The other guys are toggled off. I guess this was where radio 3 got toggled off and radio 2 got toggled on. It gets a little confusing watching all these toggles go by. But yeah, there's your toggle buttons. We did the regular toggle, and it's the same event you're really looking at, whether it's toggled or not toggled. Check buttons are the same thing. They're also, we've already looked at that. I guess we didn't look at them, but they are the same thing here. Let me pull up the, if I've got it here. Did I lose it? Yeah, I have a tendency to close things out when I shouldn't. Okay, let's see, check 1 toggled. So what does it look like? On check 1 toggled is what you see, and it gets active. Toggle boxes, regardless of the type of toggle boxes, they can be picked up with the get active, get toggle button, get active. They're very wordy. And it comes back and tells me whether check 1 is toggled or not toggled. Now, at this point in time, I could do stuff. Mumps has a database in it, which I'm not talking about. And what you could be doing is updating the database and setting things up. So, for example, I could say, for example, set up arrow TEST sub 1 equal to up arrow TEST sub 1 plus 1. Okay, that's the up arrow in front of something means it's a global array, which means it exists on disk. Then it looks like an array in a language like Fortran, where you have a open and close parentheses. Then you'll have a comma list, 1, comma 2, comma 3. Those are the indices. It's not like C, where you have a set of brackets for each index. It's more like Fortran. And so that would be incrementing something. I don't want to do it because I have to go initialize it and stuff like that. But I could do database activities there and other things. And of course, I could go out there and I could actually write something to my where's my thing here? Let's get up GTK. I'm reusing code rather than rewriting it. Okay, here is where we were setting the buffer. Capture that. So over here, and I'm getting this too big, aren't I? There's check. I don't see where. There's check 1 up here. Okay, and I'll say here, I'll paste this in. I don't need all of this. I'll say, just say something like a. Let's see. All right, and let's see what happens there. I'm not actually sure because I didn't clear out the buffer and I forget the command to close out the buffer. Now, what am I? Let's just check 1. Yeah, here we go. Well, something's not working. Did I save it? Okay. I think it got saved that time. Nope, and this is check. Oh, excuse me, it's the wrong button here. There it is. I was wondering. Now it's only doing it in one case there. I was hitting the wrong button. The checkbox is what I've been messing around with here. But I could say, something like this here. Let me go back. You get an example here, and I'm going to paste that in rather than rewriting. And I'd say if. equals 1. It's a single equal sign. And let's, oops, I think I'm in VI and I'm not. Okay. And let's down there, I'll say, you have to be careful with the word else in Mumps. It doesn't exactly mean what it seems like it is. Else set to, well, let's see. Let's just do it once, and I'll say set x. I don't know if I'm not toggled or I'll have to look at it and we'll worry about it later. Let's see, you need a blank at the beginning and blah blah blah. How am I doing here? If it's active, I'll say set x equal we've been toggled. If it's not active, I'm setting x equal to not toggled. Then I'm updating the buffer. Seems like it might work. Okay. See it? It's working. I know this is really great stuff, but yeah, here's a program I'm writing, and again, Mumps is a very primitive language. You have to obey its rules. It's not going to obey your rules. The blanks and the things like that. It's a little bit different, but it is fairly simple, interpretive language, but it's very powerful when you get into that hierarchical database, and it's very good at string handling. Well, anyway, yeah, there it is. It's two things are going on. The toggle button handler is being invoked, and as a result, you're changing something in the text buffer. Okay, you're talking to the text buffer, and it's causing a change to occur on the screen. Okay, which all sorts of things could happen. You know that at this point of what you might want to program in upon toggling something. All right, now in my case here, I got my load tree store here, which is it takes a while. There it is here. Now the tree store actually also, I believe, sets that up there. You see where I just clicked it, and you saw the line I clicked on. So I'm going to click another one here, 802.513. You see, it indicates what got clicked. Again, that's doing something similar. Let me get that off the screen. I don't need it. Where'd my edit go? Yeah, there we go. So let's look at the select. That's the select on unit that's coming up. There it is. Again, it all looks very similar. This is the column, and it gets the selection. It writes out the selection, so it's going to write out the contents of column 1 that got selected, and it wrote it out, and then there's where we set the text buffer. Buffer 1, the text buffer 1 is the business part of the text buffer, and we're putting x into it, where x is the value we extracted. Again, one of these functions that we extracted from the tree store here. Okay, so it's pulling from the tree store. Select 1 is the widget, and it's pointing into the tree store, and you're getting column 1, and it comes back and tells you the value of column 1. Let's go back over in here. Yeah. So when I let's click one down here, you see there's A03, which is the value of column 1, and it gets written to the text buffer. All right. Now you could write it out to a disk. You could do all manner of things at that point. Okay, where are all these functions coming from? Functions are coming, and I'm adding to them, and it's still kind of experimental. These in the user notes. Okay, there's a little message up there. GTK loves shooting out warnings and error messages, most of which are just a nuisance. They really don't mean anything. This is one I only just saw starting, but it's apparently fairly well known. If you don't like the easiest thing is just ignore the message. But if you don't, if you get something like this, put this line of code. I've not been getting it today. I was getting it a couple of days ago. So yeah, I don't know. And nobody seems to know how to fix it. In fact, that gets rid of it. Okay, the functions I've implemented so far are here. And there'll be more of them coming. So what are the functions? Get active, or you give it a toggle button reference and it comes back 0, 1. Set active, where you can make it active or inactive. Okay, you're going to remember when you set it active, it's going to trigger another signal, the fact that it was activated. So that can be aware of that. That has cascading consequences at times. That's true in GTK in general. Get entry text. Well, we didn't do that, but that's the stuff up here. Okay, that's an entry box. And where's my running thing back here? No, it's buried. I don't know where my program is that's actually running. This is the window that's actually causing it to run. So if I start typing stuff in here, you can see every time I type something, it comes down and tells me what it's got so far. And that's what that line is, get text. Set buffer text, which you can, we've done that. You can set the string into the into a text buffer, and $C parenthesis 10 close parenthesis is the new line character. Other ASCII characters should work as well. I haven't tried them all yet. Set label text. This is a label here. You could set the text. That's just a label, but you could change the text of it. Using the set label text, where you give it the name of the label and you give it the string you want to have put there. Let's see. Get selected. That tells you the column. That gives you the tree model, and it comes back and tells you what the value of the column is that was clicked on. It's a row that gets clicked on, but it gives you the column of the row in question. Let's see. That clears out the tree store. It zeroes out a tree store. I use it in the example. If you play with the example, because I've got a load table in here too. I haven't played with that, but if I click clear the tree store, bye, it's gone. That's what just executed that function there, cleared it out. If I do a load table, this takes a long time because it really is big, and these tree stores and so forth are not really designed to hold huge databases, but and I shouldn't be doing it. But the simple fact of the matter is it does work eventually, because there's thousands of lines that get generated. And this isn't me doing it. This is actually GTK doing it. I'm sending the stuff to GTK, and GTK is populating this table. I hope it's populating it. Eventually it'll do it. I'll just ignore it. Well, it's doing it there or something. Maybe it's not doing it. I don't know. It should be doing it. Okay, this is where you can add information to the tree store. Okay, where you give it the depth, and you give it a collection of data. There it goes over there. I'll do a separate video on this. It's much more complicated. But that's how I add things to the tree store. Spin button, get the value of the spin button. There's some notes here on adding tree views into Glade. It's not all that obvious how you do it. I'll do a separate video on all that. These are some notes on it. It's very frustrating. The only restriction here is that when you actually name your columns, they're going to be named COL1, COL2, COL3, even though internally they're going to be column 0, 1, 2, and 3, but you start off with 1 up there, and the results of I don't know what that was, a typo there, but anyway, then the actual renderers, each column has a renderer. It has to be COL1R, and so forth and so on. So I'll do a separate video on that because it is more complicated. And one of the things you have to be careful is spelling these functions, because it's obviously unforgiving. It's easy to misspell a function where the name is half a line long, and you got this $Z in front of it, which is necessary from the Mumps point of view. But yeah, so here, now the column 1 is still doing the same thing. It's also talking to me over here. It's pulling out the entire, but this is now not hierarchical. It's made a separate line for every one of them. Instead of being a tree store, it's a table now. This is just a plain old table. And I'll do those in a separate video. As you can see, there's huge numbers in them here. So that's why it took so long. But it was them taking it, not me, because it was overtaxing the way that thing's designed. And this was used as a search function. I don't think it'll work on this one, but what if I type A02 and see what happens, and see if that works? Yeah, it's searching, going crazy. Yeah, I don't know actually what it's doing. I haven't gotten that far, but it's selecting and searching through the thing, looking for A02, and it's not finding it. I think I'll put it out of its misery. Yeah, it was designed to be, oh yeah, there it is, found it, well, yeah. And it brought it up as a tree. I don't even know how my own code works, but yeah, it brought it up as a tree. Found A02. which is quite far down in the table apparently. But yeah, so, and then it loaded it as a tree store rather than as a just a plain old table. The tree stores are actually, I think, nicer. They're easier to sort through. Nonetheless, there is hopefully not too confusing explanation. Now, I'll post all of this code, so be aware of what you're seeing. I'll explain how the tree store works in a separate video, but not today.